Search and Salvage. In this module, you will learn what search and salvage means and how to carry out a search and salvage operation. You will find out what equipment and techniques you need to carry out such operations. And you will learn to calculate the volumes of lifting bags, how to use them, and work out the quantity of air needed to lift an object. Search and Salvage. There are two main types of search: for a specific object and for unspecified object. On the first type, you search for a known object, while the second involves looking for what you can find, such as in the case of collecting trash from the seabed. In order to be sure that you cover the entire area you want to check, you need to apply systematic search techniques. The first variable you need to define is the size of the search area. If the indications for finding the object are not very precise and the visibility is poor, you have to consider a large search area. In this case, it is best to divide the area into smaller ones and carry out a suitable search in each one. The minimum number of divers involved in a search is 2. There are many factors that influence the planning of a search. For example, the visibility, the size of the object, the accuracy of the estimated position of the object, currents, the number of divers involved, and their level of training, the time and equipment available for the search. Risks of search and salvage dives. The search and salvage dive is subject to particular risks. A possible danger, if using ropes and lines, is that of becoming entangled. This is why, when a search method requires the use of lines, it is preferable that the line is wound onto a reel. Another problem may be limited visibility due to natural causes or to finning techniques not suited to the type of seabed. Sometimes the visibility is so bad that you have to make the search using touch by skimming your hands over the seabed. In this case, you must be very careful not to injure yourself on sharp or pointed objects. A pair of thick gloves is absolutely necessary. During the salvage phase, the main danger is losing control of the lifting bag. If this happens, the load it is supporting could sink suddenly, maybe because the load becomes untied or because the lifting bag rises too quickly and turns over on the surface, causing all the air to spill out and the object to sink down again. This is why you should never stay above or below a lifting bag. The question you should ask yourself if you do find something in the water is if you are allowed to salvage it. With regards to wrecks, ship owners and insurance companies often maintain ownership rights. If the object found can be considered of artistic, historic or cultural value, there is not doubt in the matter. The laws in various countries generally protect any object of historical, archaeological, or ethnographic interest. Equipment. In order to carry out a search, certain special items of equipment must be available. Because it may be necessary to stay underwater a long time, suits must provide adequate thermal protection, and cylinders should be of a large capacity. To avoid exceeding the maximum no-stop dive time, you should use the best nitrox mix for the depth at which you are carrying out the search, if you have successfully completed the PSS specialization course. A dive computer, a compass, and a dive slate are items you need for nearly almost all the search methods. As some search patterns require the use of ropes and lines, good cutting tools, preferably of different types, are indispensable if you have to tackle problems of entanglement. Special equipment also includes various shot lines. A shot line consists of a weight, a buoy, and a line or rope connecting the two. If the buoy must reach the surface, the line must be longer than the depth at which the search is taking place. The weight must be heavy enough to make the buoy sink slightly. Otherwise, even a slight current could drag it away. To salvage an object, you need to use a lifting bag, a type of plastic sack, open at one end, known as the mouth. There are many different types of lifting bags, from those providing a few kilograms of lift to those that provide thousands. When in use, the mouth points towards the bottom, so as the bag begins to rise, the air inside expands and escapes out of the mouth to prevent the bag tearing. The lifting bag should be chosen so it works at its maximum capacity. If, for example, you need 150 kilograms, 330 pounds of lift, it is best to use a 100 kilo, 220 pound and a 50 kilo, 110 pound bag, rather than a single 300 kilogram, 660 pounds one. In the case of the 300 kilogram, 660 pound lifting bag, the air would expand during ascent, resulting in a maximum lift of 300 kilograms, 660 pounds, while in the case of the two bags, the excess air would escape, leaving the 150 kilograms, 330 pounds of lift unchanged. However, in order to use the lifting bag, even when it is semi-inflated, the upper part of the bag is fitted with a dump valve that can be activated by a cord and knob that dangles from below the mouth of the bag. This means that the diver can operate the valve while staying to the side of the lifting bag. If you do not have a lifting bag, you can improvise by using one or more plastic sacks inside a strong net bag that has the task of sustaining the weight of the object, but the lack of the dump valve limits its use. In order to secure the object, it is a good idea to practice tying various types of knots. The main characteristic of a knot is that it should be strong and that it can be untied easily when necessary, even when under tension. Your instructor will have you practice some of the most common knots, which will also come in useful during your other diving activities. Search patterns. One of the simplest methods is a bathymetric search, which is particularly suited to sloping seabeds when the only information known is the depth of water in which the object was lost. So it is possible to make a search by following the seabed at a constant depth. The search area should cover quite a large area, with the estimated point where the object was lost in the center. In this case, the departure point for the search starts at one of the corners of the deeper side of the search area. The first leg is made by following the seabed at a constant depth. On arriving at the other corner, decrease the depth, following the seabed at a distance that depends on the visibility, and return to the other side, following the seabed at this new depth. Continue like this until the entire area has been searched. This search method is not very systematic and is therefore rather imprecise. However, it does not require the use of a line or a compass. A circular search does not require the use of a compass either, but it is more systematic. A heavily weighted shot line is deployed in the estimated point where the object is thought to be, which in this case also corresponds to the starting point. The shot line acts as a fulcrum for the circular excursions, and the distance is established by using a thin line attached to the shot line in such a way that it is able to turn around freely. A reference point is established using a line or a weight. This marks the point where the divers extend the radius of the search. The divers swim the first circle of the search while looking for the object on the seabed. Every time a circle is completed, you return to the reference point and move further away from the center at a distance that depends on the visibility. So, on reaching the reference point, a certain length of line is let out and another circle is made, concentric to the previous one. This process is repeated, every time letting out a length of line equal to the visibility, until you have completely searched the area. The semicircular search pattern is a reduced version of the circular search. For example, imagine that something has fallen off the side of a jetty. In this case, we can't make a complete circle because the jetty limits the search area. So we make a semicircle. In all the searches consisting of straight lines, a compass is used in place of the search lines. The U-search pattern is one of the simplest search methods. Once the search area has been defined, you start from one of the sides and swim in a straight line along its length that should be between 20 and 40 fin cycles. At the end of this leg, you turn at 90 degrees and swim a distance equal to or slightly less than the visibility, and then turn again and swim parallel to the outward leg for the same number of fin cycles. This search pattern has the disadvantage of being affected by the current. To limit the effects, it is best to use a search pattern in which the movements to the side occur against the current. Another search pattern, this time using a compass, is the square spiral. However, this type of search can only be used when there is no current. Salvage. Once the object has been found, you can pick it up with your hands only if it is very light. If the object is heavier than 5 kilograms, 11 pounds, the first thing to do is tie a surface marker to it, so you can find it again, and ascend, so you can carefully plan the salvage procedures. In the case of heavy objects, it is necessary to use lifting bags. Remember to be ready to operate the dump valve to control the speed of the ascent. The weight of the object in the water is less than on land. This difference is due to the upthrust cited in Archimedes' principle. It is possible to make a quick calculation of the weight of an object in the water by subtracting the weight of the volume of water displaced by the object from the weight of the object. If the volume of a solid object is not known, you can work it out by knowing its specific weight. For example, if the object is made of iron, the specific weight is 7 kilograms per litre, 435 pounds per cubic foot. So an anchor weighing 14 kilograms, 31 pounds, would displace a volume of water equal to 14 kilograms, 31 pounds, divided by 7 kilograms per litre, 435 pounds per cubic foot. That is 2 litres, 0.071 cubic feet of water. In the case of salt water, with a specific weight of 1.03 kilograms per litre, 64 pounds per cubic foot, the upthrust is equal to 2.06 kilograms, 4.55 pounds. So, in the water, the anchor weighs about 12 kilograms, 26 pounds. To estimate the volume of air you need to put into the lifting bag, just calculate the volume of water that would give an upthrust equal to the weight of the object, and subtract the volume already displaced by the object in the water. So the volume of air needed is equal to the weight of the object divided by the specific weight of the liquid minus the volume displaced by the object. It is possible to calculate the normal liters, normal cubic feet of air to put into the lifting bag by multiplying the liters, cubic feet of air by the absolute pressure at the depth at which the air is being put in. Or rather, normal liters, normal cubic feet equal to the volume of air needed multiplied by the atmospheric pressure, which is 1 plus the depth in meters divided by 10, or in feet divided by 33. Instead, to work out the fall in pressure in the cylinder, just divide the normal liters by the capacity of the cylinder. Have fun!